Alrighty, let's get this thing started. I found a video on Capturing Christianity's channel, like a year, I think it's a year or two, maybe a little over a year old, so it's been up there for some time. But I just came across it and I started watching it. It is interesting, the framework that's taken here and the argument that's presented, but I thought that it would be a good video to share with everyone.
Hey, welcome to
I didn't click play. What are we doing? And kind of talk about and see if other people have similar thoughts about this video as I do. So we're just going to get right in it. The title of the video is "If You Like Science, You Should Hate Naturalism" with Dr. Tomas Bogardus. And yeah, I'm just gonna leave it there and get this going.
Hey, welcome to Capturing Christianity. My name is Cameron Bertuzzi, and today what we're talking about on the stream is if naturalism is true, then scientific explanation is impossible. This is a new paper that was published by one of my favorite guests, Dr. Tomas Bogardus. He's joining me today from California, and he's written this paper. He's titled it, "If Naturalism is True, Then Scientific Explanation is Impossible." It's forthcoming in Religious Studies from Cambridge University Press. So welcome back to the show. First of all, it's great to have you here.
Thanks very much, Cameron. It's good to be back.
Yeah, so let's talk. I'm a little bit overexcited to talk about this paper with you today. I can't wait to talk about. I mean, I'm always looking for like any excuse to have you on the channel. So when I saw that you posted that you published a new paper, I was like, okay, immediate. We're gonna have him back on. So let's just jump right in. I mean, I feel like you've been on the show enough times where. Why don't we do this? If you'd like to learn more about Dr. Tomas Bogardus, check the link in the description. I've got a link to his academic page. But other than that, let's just jump. I want to jump straight into the topic here. I've got some slides prepared, but I'm going to let you just do your normal thing and just guide us through. So where would you like to begin in discussing this this new paper that you've got published here?
Well, I thought it might help to talk a little bit about the origin of the idea and where the paper came from, to give a sort of overview of the arguments. So I think this paper might set the record for me for the longest gap from when I first thought of the idea to when I actually published it. I think the idea first came to me and I first started thinking about it. I think it was back in 2012 when I first started teaching after my PhD program. I would assign students a video. I'd have them watch a video on YouTube. I think it's called 50 Renowned Academics. It's interacted, or Bill Craig interacts with his work a bit when Craig's working on Kalam. If the laws of nature were the two, you use
trying to find a point where he really starts to explain what his argument was.
And I often wondered, why are they the way that they are? Reflected on the laws of nature before. He said, "I admit I have no idea why the laws of physics are what they are." So that wasn't a new thought to me. I had sort of reflected on the laws of nature before. I found them really interesting. Studying as I did biology as an undergrad and in high school, I was always really fascinated that there were these laws that we could use when doing science. And I often wondered, why are they the way that they are? But the bit of Guth's quotation that really struck me and got me thinking was the second bit where he says, "I have no idea how to go about approaching that question." I have no idea how to go about approaching the question of why the laws of physics are the way that they are.
This is just an idea. I don't know if I would say that it's probably true, just because I don't think humans yet know enough about physical reality, as seemingly counterintuitive as that may sound. But it could be the case that at least the fundamental laws of nature just are the way that they are, and that there is there would be nothing underlying them that would provide for an explanation of why they are the way that they are. And kind of a bit of a preface for some of the topics discussed in this video. I didn't watch the whole thing, but I did kind of skim through it and everything, because you know me, I don't like to watch the full thing before I do a stream on it, because then it actually gets kind of boring watching that video again, a day or two later. Anyway, I do think that explanations ground out at some point. And even I think theists believe that. They just think that they ground out normally in God. And then God, you know, being a necessary being, a necessarily existent being himself, has no explanation. He is self-explanatory. I don't take that view, obviously, but I would say that I do think explanations ground out somewhere. Where that is, I don't know. I would suppose, at least for like matter, maybe energy as well, it grounds out in quantum fields, that quantum fields are non-composite. There is nothing sort of undergirding quantum fields as far as we know and as far as we can pick up from the physics that we have. Quantum fields sort of sit at the bottom of reality, so I think that could be a place where explanations ground out. You know, I'm not a professional physicist, so
And that struck me because I realized.
But the general idea, I should say, there is that I think that there's a point where they're just explanations stop there. There might be features of that ground that themselves are unexplained. They just are.
If you're a naturalist, if you're an atheist, as Alan Guth is, then there is a real puzzle here, because the laws of nature are something that you use to explain everything else. To think about it in a sort of simple way, you use, as a scientist, if you want to explain some natural phenomenon, you use initial conditions and you use laws of nature. And these laws of nature are kind of like bridge principles that tell you, well, if you start with these conditions, then the laws tell you here's what's going to happen later. And so that's how
that's accurate. Obviously, it's simplistic, but it's accurate.
You explain natural phenomena as an atheist, as a naturalist. Initial conditions, laws of nature. Initial conditions, laws of nature. So if you ask a naturalist, why are the laws of nature the way that they are? Can you explain these to me? Then the naturalist is sort of at a loss, because these were the things that we were using to explain everything else, you know? And so if you ask, well, can you explain this? Then I think that's why Alan Guth says, I have no idea how to go about approaching that question, because what tools will you use to explain the laws of nature?
Well, it is an interesting question. You know, how would you explain the laws of nature? Can you explain the laws of nature? But I would honestly like to quote William Lane Craig here. At least this is when I first heard this, it came from him. He might not be the person who originated this idea, but you don't need an explanation of if you have some explanation and it succeeds at what it aims to explain, that you're fine. As long as you're within your framework and everything like that, you're fine. As long as you're not taking the explanation beyond what it aims to explain, you're okay. You don't need and you might seek out, but you don't need an explanation of the explanation. So I guess that is a thought that I would implant right here in this discussion.
If the laws of nature were the tools that you were using to explain everything else. Does that make sense? So that was one bit of the puzzle that got me thinking. And then around the same time, my daughter was much younger then. This was like 10 years ago. We were eating lunch together, and she sneezed. I think she was about 3 or 4 years old, and she sneezed. And I just, not really thinking, I just said, "God bless you." And I guess that was the first time anyone had said it to her, or that was the first time that she noticed it. And so she asked me, why did you say God bless you? Why did you say that? And that's a reasonable question. And so again, I was like eating lunch, and so I wasn't really reflecting on what I was saying. And I just said, we always say God bless you to people when they sneeze. You always say God bless you when people sneeze. But then she kind of put her fork down, and her eyes got wide, and she was like, why do people always say that? And so then, and so it occurred to me that my explanation didn't really help her at all. In fact, it made things a lot worse for her. She was confronted with a little bit of mystery when I said, she sneezed, and I said, God bless you. And she was like, oh, that's weird. Why did you do that? And then my explanation was, oh, don't worry. This always happens. And then I think the reasonable response, and it takes a child to do this, is the reasonable response is to think well, why does that always happen? I was wondering why it happened on this one occasion. And now you're telling me it's happened many, many times. Why has it happened so many times? Now, of course, like we can give a further explanation of that sneeze law, you might call it. Like if somebody sneezes, say God bless you. We can give an explanation of why we do that. And I've heard different kinds of theories. It doesn't really matter. But if I had ended the explanation there, if I had said, no, that's just what we do. If somebody sneezes, we say God bless you, and there's no further explanation. That's just the way it is. That would have been deeply mysterious for her. I don't think she would have been in a position to understand why I said God bless you on that occasion. And so
Also, I should point out that saying something after people sneeze isn't this sneeze law, so to speak. It's not something fundamental to reality. So, you'll often hear this idea of, oh, well, not having an explanation just seems counterintuitive. That doesn't seem right. I can agree with that when we're speaking at a scale where there are things which underlie the events that happen. But once you get down to a scale where there may not be any underlying events at all, you're going to be working with a different framework. You're going to have to take a different framework. And that's why, like I said earlier, a potential position is that fundamental laws have no further explanations. They are just fundamental laws, and they are just that way. Because you're at that fundamental level. You're at that level where there aren't things underlying what's going on such that they could provide some explanation for those laws. And so I think in our everyday lives, asking for explanations of things is perfectly healthy to do. I don't think there's anything wrong with that. But when you're talking, quantum field theory or something like that, or fundamental laws of reality, I think the discussion changes a little bit. And that notion of explanation just might not exist at that level. And while that might seem counterintuitive, I don't think that's an argument against it. The fact that, well, I just don't like that. It doesn't make me feel good not having a fundamental explanation for everything. Well, that's fine. That doesn't really settle anything for you, but that might be the way that it is.
So it was sort of those two things.
So I think that I should clarify, I think there's this distinction between asking for explanations in our everyday lives and at the scale that we exist at, and then projecting that down to the fundamental level of reality, where I think things take a different shape, so to speak.
Put together that resulted in this paper, Alan Guth's observation that, like, as a naturalist, it's hard to even know how you would go about explaining laws of nature. And then my realization with my daughter that, like, if you appeal to a law in an explanation or a rule or a principle, if that principle or law is unexplained, then the explanation fails. So if you put those two thoughts together, you get the main argument. So I had asked you if maybe you could display that main argument on slide.
Is now a good time to do that?
I think now would be a good time to do that. Yeah. Okay, so eventually this is 10 years later.
And obviously I've seen this because, like I said, I skimmed through the video, and most of what we've been watching I did actually sit and listen to. This argument is not like immediately problematic. Oh, like this is so bad. It's a terrible argument. There might be people who think that, but the first place where I have an eyebrow raised is premise 2 here. Any explanation can succeed only if it doesn't involve anything that calls out for explanation but lacks one. I just that seems conceivable to me. It seems conceivable that we can have explanations that themselves aren't explained. And like I said, you don't need an explanation for the explanation. If you have an explanation and it works, it explains the thing, but maybe there's something in that explanation that itself isn't explained. I think Thomas later clarifies that it's not just that it lacks an explanation, it's that it actually just doesn't have one. And even then, I'm not seeing how that would somehow sour the whole explanation or even potentially explanatory chain that exists sort of above that. So premise 2 is certainly, for me at least, the most problematic one that I see here.
This is how I ended up developing that argument. So there's only 3 assumptions in here. One, premise.
And just quickly, well, actually, no, I think he's going to read it out.
1, premise 2, and premise 4. And then 3
Maybe.
follows from 1 and 2. 5 follows from what came before. So we'll just look at the assumptions one at a time, and I'll try to defend each one.
So the argument is premise 1, and I'm doing this for anybody that might be listening to this now or later that isn't actively looking at the screen. The argument is premise 1. Any scientific explanation can succeed only if it involves a natural regularity. I can grant that premise. I would say it seems true to me, but I do have a feeling that there are probably some theoretical physicists out there that would say, well, but I'm not a theoretical physicist. I do study physics, but I'm not going to raise any issues with premise 1. Premise 2, any explanation can succeed only if it does not involve anything else that calls out for an explanation, but lacks one. Premise 3, so a scientific explanation can succeed only if it involves a natural regularity, and this regularity does not call out for explanation while lacking one. 4, if naturalism is true, then every natural regularity calls out for explanation but lacks one. I'd also take issue with premise 4. I don't think that's necessarily true. 5, so if naturalism is true, then no scientific explanation can succeed. I would just grant the argument is valid. The conclusion follows from the premises, but premise 2 and premise 4, I definitely take issue with. So that's the argument for anybody that's just listening.
But maybe we'll just read them right now. So premise 1 says, any scientific explanation can succeed, but only if it involves a natural regularity.
Little bit less restricted as a phrase.
The sort of principles of the special sciences that would admit of exceptions, or even principles of sort of folk science that would admit.
Okay. I should be back. I don't know if I'm back strongly. I was on the 5G network, and that's kind of got a weaker range than just the regular network. And I dropped off that network and quickly connected to the regular one. So hopefully everything should be good now. I paused the video. I'll rewind it a couple seconds here. I don't know if I'm back. It shows me back, but I don't know. I'm just going to give it a couple seconds and make sure that this Wi-Fi signal is going to actually stay connected, because if not, then I'll probably do this a different day. But every now and then it likes to disconnect and then reconnect and then disconnect and then reconnect for like 5 or 10 minutes. So I'll just sit here and chat with you guys for about a minute or two and just make sure, actually watch my Wi-Fi, my little mini Wi-Fi screen, and make sure that the signal stays connected before continuing on. Because like I said, if it's just going to keep dropping, then I'll probably just reschedule, because I'm not in the mood to deal with that. So I can see some familiar faces in the chat. I see Michael, James, Pragmatic Crystal. I hope everybody's doing well. Yeah, and hopefully we can get back to this, because this video was interesting to me, and I want to actually cover this. I think it's an interesting topic. And actually a rather interesting argument I think that Thomas has here. I don't agree with it, but I think it is a rather interesting argument. So it looks like everything's going to stay connected. Let me play the video and
Got
just
to
double check
feature
here.
a natural regularity or a law of nature. So that was that first part of that first observation from Alan Guth. Like if the scientist is just using, when we do science.
And the funny thing is we have a signal booster upstairs. So I don't know if it's the signal in the house going out or something, or if it's like the actual Wi-Fi, not a distance issue, but the Wi-Fi is actually just kind of going in and out. I mean, I live in a rural Iowa. We do have fiber optic, but you know, and it's a sort of a smaller local cable business that we go through. But I'm pretty happy with the service that we have here in the house for the most part. It's pretty strong. It tends to you know, hold true. There's these little burps and hiccups, but hopefully everything stays strong going forward.
If we're just using initial conditions and laws of nature to explain everything, then part of scientific explanation is the laws. The laws are a part of scientific explanation.
Yeah, it sucks sometimes.
Okay, so that's premise one. And then premise two is a necessary condition on just explanations generally. And it says any explanation, scientific or otherwise, any explanation can succeed, but only if it doesn't involve anything that calls out for explanation, but lacks an explanation.
Now, the wording of this premise also is a little rocky for me, because just by taking this wording prima facie, I could point to examples of where this exact thing, what the premise is saying, obtains, but we still have a perfectly good explanation. General relativity as a theory. That I would say that there's a feature of general relativity that cries out for explanation. And that's why mass energy curves space-time's geometry to begin with. Not just what results from that curvature, which is what general relativity tells us, but why mass energy even curves space-time to begin with. Because there's nothing in general relativity says absolutely nothing about that. But we don't have an explanation for why mass energy curves space-time, at least not yet. And this is why later on Thomas says that it's not just something that in principle could have an explanation, but we just don't know what it is. It's something that cries out for explanation, but actually just doesn't have one. Not that there could be one and we just don't know what it is, but that there isn't one at all. And that's where on premise two, I might consider trying to find a way to reword it to sort of make that it does not have an explanation at all. Not even in principle, even though it cries out for explanation, to try to make that point a little bit more prominent in the premise, because to me, it seems that somebody could use, like I just did, an example of something that is unexplained and cries out for explanation, but still has an in principle explanation. There is in principle an explanation for why mass energy curves space-time. We just don't have a quantum theory of gravity yet. We don't have that explanation on hand, but pretty much every theoretical physicist would say it's out there. Like, there is a reason why mass energy curves space-time's geometry. We just don't know what it is yet.
So I'll spend some time explaining and defending that, because I think that's the most controversial premise. So we'll think about that one.
Well, Thomas, I think, reads that correctly, because I immediately take issue with premise two. And it seems like that's probably going to be the most controversial one. I think four is controversial for me. I don't know. I wouldn't say every natural regularity calls out for explanation, but lacks one. I would also say calls out for explanation. I kind of get what Thomas means by that, but I don't think that things that lack explanations necessarily have to call out for them. But that might just be a specific point he's adding to the premise to specify it more.
That one a bit, and I'll share with you some counterexamples that people have proposed as I've shared these ideas.
Yeah, that's the one that I take issue with too.
Yeah. Okay, but if 1 and 2 were true, then would follow that, okay, here are
And just to add a little bit more onto this premise two thing, even if there were no in principle explanation for why mass energy curves spacetime, the fact that it does and that we can make predictions based on that and that there are, pseudo forces that we can explain using that, I don't think somehow gets thrown out the window. I don't think that general relativity as a successful theory today would somehow be thrown out because there is no in principle explanation for why mass energy curves spacetime. I don't see myself how. Maybe there is somehow some sort of like metaphysical or logical reason why general relativity would completely fail as an explanation for things that simply result from mass energy curving space-time. But I don't see why. I don't see why general relativity would have to be thrown out, even if there were no in principle explanation of why mass energy curves space-time.
There are two necessary conditions for a scientific explanation to succeed. It's got in.
So I guess I would say that I think premise two is false, that you can have explanations even if there are parts of them that call out for parts of the explanation that themselves call out for explanation but lack one.
Involve a natural regularity, and this regularity better not call out for explanation but lack one. Okay, and then premise 4 says, hey, if naturalism is true, then every natural regularity, every law of nature is the sort of thing that calls out for explanation. I'll explain what I mean by that. But literally lacks an explanation. There is no explanation for laws of nature on naturalism. Okay, and then from 3 and 4, we get, well, if naturalism is true, then no scientific explanation can succeed. And of course, I invite you to run a modus tollens on 5 and conclude that naturalism must be false, given the success of science. It's an incredible track record of successful explanation and prediction. If naturalism entails that that's impossible, so much the worse for naturalism.
Another issue I see here, and I'm sure that Thomas would probably have a response to this with respect to defense of this argument, but at least the physical sciences, and I would say the social sciences maybe to some extent, but certainly the physical sciences are sort of embedded within a naturalist framework. Now, we tend to call that methodological naturalism. It's not the statement that there isn't or that there can't be supernatural phenomenon. It's just that we don't assume that there is in our examination of the world around us, unless and until something would come along that openly and overtly rather indicates that there are such things, and obviously we haven't seen that. So given that at least the physical sciences themselves are sort of embedded in a type of naturalist framework, that I would just wonder how Thomas would respond to that point, I guess.
Okay, so that's the argument. Let me start by thinking about premise 1, and then I'll talk about premise 2.
Okay, let me mention this as we get into the first premise, is that I've got his paper linked in the description of this video. So if you're interested in reading like the full paper, it's free. You can go read it right now. You can even read it like as we're going along through each different premise. But what we're going to do here is just kind of summarize some of the ideas. We're not going to, he's not just going to like read his paper out right now. We're just going to look at some of the things that happen in there, because there's a lot more in there than we'll be able to get to today. So, but I did just want to highlight the fact that if you're interested, you can go read the paper right now. So, yeah, so let's get into premise 1. Yeah.
All right. So I thought first we should probably just briefly mention what naturalism is. I like Alvin Plantinga's definition of naturalism. Alvin Plantinga says, according to naturalism, there is no God or anything at all like God. So of course that's kind of vague because it's unclear how like God something has to be in order to be inconsistent with naturalism. But I think naturalism itself is vague, and it's often unclear whether a view is
I I hear this a lot, but I just don't think it's true. I think when people talk about naturalism, everybody has an idea of what's being talked about. That there aren't any things like gods or supernatural entities, ghosts, angels, demons, devils, spirits, spiritual powers, things like that. I think everybody kind of has that notion when they think of naturalism. The way I like to define it is that naturalism is just the metaphysical thesis that the natural world or the physical reality that we inhabit is all which exists, that it is this isolated and causally closed entity, that there's no such thing as an outside of it or beyond it. And so there's no sorts of entities or forces that could be defined as existing outside or beyond it. There is this natural physical reality. It's isolated, it's causally closed, it has regularities or what we might call natural laws in it, and we can understand it. So I think that's a better way of really understanding what naturalism, at least as a metaphysical thesis, is supposed to be. And I don't think that it's very vague. I think that there might be a few different ways that people might define naturalism, or even a phrase like the natural world. But I think that there's a general idea of a lack of divine or supernatural entities in existence, that such things do not exist.
Naturalistic enough to be a version of naturalism. So I think that Alvin Plantinga's definition is big, but naturalism is big.
Josh Rasmussen has like his own view that he thinks that God is compatible with naturalism, depending on what we mean by naturalism.
Yeah, it's a good thing you added that last part there, Cameron, depending on what you mean by naturalism, because by definition, God could not be compatible with metaphysical naturalism as it's generally laid out, that there are no gods, that there is nothing divine or supernatural. And since God would be classified as a divine or a supernatural agent, then it just can't be the case that God would exist within a naturalist framework, which by definition excludes God as an entity that exists. Now, obviously, naturalists accept the idea of God, the concept of God, of course, but that there is such an entity in the world is rejected by most naturalists who hold to naturalism as a metaphysical thesis, which is generally what naturalism is given as. Generally, when somebody says, I'm a naturalist, that's what they're saying, is that divine or supernatural things bear no existence.
Okay, I guess I'd want to hear what we would mean by naturalism. Yeah,
that's why the term itself, I'm not a huge fan of the term naturalism, as I think that you know that, but I'm also happy to go along with this definition that you just gave from Plantinga. I think that probably is like the best definition out there.
Well, share one from your buddy Graham.
I'm sorry, I think it's a rather poor definition, if I'm going to be completely honest.
Oppie as well. He said, naturalism is the view that science is our touchstone for identifying the denizens of causal reality. Science is our touchstone for identifying the denizens of causal reality. So I think that means science is probably the best way, or maybe the only way, but at least the best way to figure out what exists. And he says, there are none but natural causal entities with none but natural causal powers. Okay, so that's the definition of naturalism according to Graham Oppie. Only natural stuff exists. So if you didn't understand what supernatural entities were, or if you didn't already understand what natural entities were, this definition is not going to be very helpful. And science is the best way to figure out what really exists. Okay, so I think that's typically what people mean if they say they're a naturalist. And I think this is a view commonly held by atheists. It's a kind of combination of a very austere, sort of minimal metaphysics, basically a kind of materialism or physicalism, plus a broadly empiricist epistemology where we're privileging science as a means to learn about what really exists. Okay, so that's what naturalism is. And let me just briefly say something about premise one, although I think that's probably the least controversial premise. Premise one just
I'll put it back on the screen.
Okay. So premise one says any scientific explanation can succeed, but only if it involves a natural regularity. So a very important and still influential view about the structure of scientific explanation was called the deductive nomological model of scientific explanation, the DN model. And on this view, scientific explanation consists of two things. You've got the things that are doing the explaining and the thing to be explained. The explainers and the thing to be explained. The explanans and the explanandum. The explanandum, the thing to be explained, is just a description of the phenomenon that you're interested in. Maybe the current position of Mars or something. You want to know why Mars is located where it is. Or maybe you're in a chemistry lab and you're wondering why this solution is now boiling or something like that. I've got a beaker of water. Why is it boiling? I want to know the explanation of that. That's what it is. That's what's to be explained. The explainers, as I said earlier, consist of two things. You cite some initial conditions, and then you cite a law of nature. So that's why it's called a deductive nomological model, because a law needs to figure in to the explanation. And then
he didn't really explain the deductive part. So he mentioned explanans, the thing that does the explaining, and the explanandum, that which is to be explained. But the deductive part is this idea that the explanans, or rather the explanandum, sort of needs to like follow deductively from the explanans. So there's this notion of a sort of deduction in the relationship between the explanans and the explanandum, and the explanans should include at least one law of nature, or perhaps, as Thomas might put it, natural regularity. Thus, you have the nomological part of it. Nomological, oftentimes referring to law of nature or a natural regularity, a law of physics, something like that.
And the idea is...
I should also specify the DN, the deductive nomological model, is only one model of scientific explanation. There's the causal mechanical model, the SR model. I think, was that Wesley Salmon? I actually don't know how his last name's pronounced, if it's pronounced like the fish or not. I just assumed not. I think developed, what is that? The statistical relevance model, I believe. So there's a lot of different models out there for understanding scientific explanation and sort of what its structure is and how it works. I personally don't favor one, but that's because of my extent of understanding scientific explanation is like reading the Stanford article on the subject. I haven't really looked into it to like think about these things deeply and come to a conclusion as to which model I might prefer. But I do know that there are like 3 or 4 different, at least prominent ways of looking at this. So the deductive nomological model is not the only one, and does have its own problems, like the causal mechanical model does, like the statistical relevance model does. They do have some issues with them, things that they don't quite seem to capture correctly.
The initial conditions and these laws will entail, like in the form of a deductive argument, will entail, it'll just be kind of a modus ponens argument, will entail the thing to be explained, the description of the phenomenon to be explained. So if we were explaining the position of Mars, we might cite like where Mars was a week ago, plus some of Newton's laws of motion or something, some laws about gravity. And we'll say, given those initial conditions, plus these laws, you can see why Mars has the position that it does now. And that's sort of what Newton did that made him so famous. That's one of the things that made him so famous, that sort of explanation of the movement of the heavenly bodies. Okay, so there have been some worries and developments and objections to this deductive nomological model, especially concerning explanatory asymmetries and explanatory irrelevancies, but we probably don't need to talk about those. It's my understanding that, as far as I can tell, all current views about how scientific explanation works agree that laws, these sorts of regularities, are going to play a crucial role. They're going to play a role in scientific explanation. That's sort of what science is in the business. That's what it's in the business of doing, telling us how it is that we should expect the future from the past. It sort of arranges the order of the universe in this temporal order, according to a relation of expectation. It tells us like what to expect given how things are now, or what to expect given the way things were then. And if we're going to develop that sort of expectation relation, we're going to need these sort of bridge principles, these laws. So that's what science is in the business of doing. All right, so that's premise one. But let me talk a little more about premise two, because I think that's the most controversial premise, as I said. So premise two is the one that says any explanation can succeed, but only if it doesn't involve anything that calls out for explanation but lacks an explanation. So before I give examples, let me just clarify some of the terms in there. By calls out for explanation, if something calls out for explanation, what I mean is it's the sort of thing that could be explained. In principle, it's the sort of thing that could be explained. And other things being equal, if you've got two theories and they're equal in other respects, but one of the theories does explain this fact, then that's better. That would be better for the theory to do it. So if something calls out for explanation, that means it can be explained and it would be good for it to be explained. It's the sort of thing that we want to explain. So that's what it is for something to call out for explanation. And I don't know if that's equivalent to, but I think a rough guide is just contingency. I would think that anything that's contingent probably calls out for explanation. Anything that could have been some other way is the sort of thing that we would rightly wonder, why is it this way rather than some other way? Okay, and when I say that a successful explanation can't feature something that calls out for explanation but lacks one, I mean literally lacks an explanation. I don't mean that we just don't know what the explanation is, but maybe there is one. I mean there literally is no explanation. So that's what it is to lack an explanation. There literally has to be no explanation in order for this premise to be violated. So let me give you some examples. Imagine that we live in an earlier time where we think that the Earth is flat. I guess some people still do think that. So just imagine you're one of those people who thinks the Earth is flat. And a question naturally arises, why is the Earth so stable? Why isn't it rising or falling or tipping back and forth or sort of spinning around? Why is the Earth so stable? And this is something that flat earthers wonder about, I understand. Now imagine we were given this explanation. We were offered this explanation of why the Earth is so stable. The Earth is stable because it's being held up by elephants, really big elephants who are very strong and they don't move quickly or something like that. So is this an explanation? I mean, of course it's false. I guess I need to mention that because some people have objected that the Earth is not flat and there are no elephants. Yeah, I know that. But I'm just wondering, like, hypothetically, if this were true, would we say that the stability of the Earth were explained? Would we say that that had been explained? So I think there is, some people experience a temptation to say like, oh yeah, now I understand why the Earth is so stable. It's held up by these elephants. But I think that if you reflect on it a little more, I hope you'll agree with me that the correct answer is actually, it depends. Whether or not we have an explanation of the stability of the Earth depends on whether or not we have an explanation of these turtles, right? Because now we're wondering, or sorry, they're not turtles, they're elephants. It depends on whether or not we have an explanation of these elephants.
I guess I don't see why. I mean, to go with the example, if there are big elephants holding up the Earth and they provide for its stability, then with respect to the question of why the Earth is stable, we have an explanation. Now, if you want to ask a different question about the elephants, which would require a different explanation, that's fine. But insofar as the initial question, why is the Earth stable, that's answered. It's because of the elephants. It's perfectly balanced, say, on the backs of these elephants, or something like that. I just don't see where the elephants come from, or why they're there, or why it's elephants that are holding it up, or anything like that is going to matter to why the Earth is stable because of the elephants.
Because now we're wondering, where did these elephants come from and why are they so stable? What's holding them up? You know, why aren't they moving around? Why aren't they rising or falling and so on? So we've sort of written a check or written.
And that's a good question to ask. But if there were no answer, no explanation as to why the elephants were so stable, it wouldn't matter to the question of why the Earth is stable. The elephants are stable, and from that we can deduce the stability of the Earth, and so that is explained. The stability of the Earth is still explained. It's just that the stability of the elephants is not explained, but that's a different question, mind you, than the stability of the Earth.
A promissory note. We've like promised to explain the stability of the Earth, if only we could explain these elephants. But if we don't have an explanation for the elephants, then I think the stability of the Earth is still mysterious. Because suppose the story ended with the elephants. We were told, okay, the Earth is held on the back of these elephants, and that's the end of the story. The elephants aren't being held up by anything. There's no explanation of where they came from or why they're so stable. Then I think the right thing to think is we don't really understand why the Earth is so stable now. In fact, things have kind of gotten worse, because now we were wondering, why is the Earth so stable? We were told about these elephants, and now we've got two things to wonder about. Why is this whole system so stable? The flat Earth plus the elephants. Okay, and I don't think it helps to like add another layer and say the elephants are on the back of a turtle, because there too we'll wonder, well, why is the turtle so stable? And again, the point right now is just, if we ended there with something that literally has no explanation, maybe it's the turtles or maybe it's the elephants, then the lack of explanation sort of works its way up back to the original phenomenon that we wanted to explain.
That's what I would be rejecting. I don't see how that works. We know why the Earth is stable, because it's on the back of elephants. Now, if you want to say, so why are the Earth and the elephants both stable? Again, different question. We might not know the answer to that one, but we've got the answer. We've got the explanation for why the Earth is so stable. It's because it's on the backs of these elephants.
I think that we're in no better position than we were before to understand why the Earth is so stable. Okay, another example is the one I mentioned earlier with that sneeze law, and this one's a little more relevant to our purposes, because what I want to wonder about is these natural regularities on naturalism, or these laws of nature. So it's actually more relevant to think about cases like that where we have a law that doesn't have any further explanation. So think about that sneeze case again. My daughter sneezes. I say, God bless you. She says, why did you say that? I've got these initial conditions, right? You sneezed. And then I've got this regularity that says, if somebody sneezes, then say, God bless you. But what I want you to reflect on now is, suppose that there really were no further explanation for why we say God bless you when people sneeze. It just happens. And again, it's not that we just don't know what the explanation is. I need you to imagine that there literally is no explanation. It just happens. People just say God bless you whenever somebody sneezes. I think then it's pretty clear that it would be totally mysterious why I said God bless you on that occasion. Because we don't know why this law is operating. Why is it that everybody says God bless you when somebody sneezes? Or here's another example. This one's totally fictional. This never actually happened to me. But suppose you buy a new house, you move into a new neighborhood, and the first Wednesday that you're living there, one single orange shows up on your doorstep. It's just one orange. And so naturally you're wondering, why is this orange here? And so you ask your neighbors, why was there an orange on my doorstep? And suppose the neighbors say something like this, oh, well, it's Wednesday. Everyone in this neighborhood gets an orange on their doorstep on Wednesday. So I think it's like the sneeze case. Like, things just became more mysterious. Like, now you realize, oh, it's not just my doorstep, it's every doorstep that got this orange. Why is that happening? Now, it could be that there is a further explanation of this orange law. Maybe there's, some benefactor in the neighborhood who just likes giving out oranges and every Wednesday does it. That would demystify things, I think. But what I want you to imagine is that orange law literally has no further explanation. It just happens that every Wednesday an orange shows up on your doorstep if you live in this neighborhood. That just happens. That's the way the universe is. There's no further explanation. Then I think it's pretty clear, like in the sneeze case, that we're not in a position to understand why this orange shows up on the doorstep. It's mysterious. What you've come to realize is that you live in a deeply and irredeemably mysterious neighborhood. And insofar as this neighborhood's in the universe, then a little part of the universe is deeply and irredeemably mysterious. There's this very strange law that just keeps happening, and it obviously calls out for explanation. Like, why do we keep getting these oranges every Wednesday? If there literally is no explanation, then I don't think we're in a position to understand the oranges. Okay, and I think that's because, like, when you're told this explanation by your neighbors, oh, it's Wednesday. Every Wednesday we get an orange. This mysterious law leaves a sort of gap or a hole in the proposed explanation. You don't understand the law. This law that they're appealing to you, this law that they're appealing to, this law that they're describing to you is mysterious. And so I think that's why the explanation fails. And let me just say one other thing before I tell you about a couple of counterexamples, because I'm trying to forestall the counterexamples as best.
I understand. This might just be nitpicking a little bit, but I understand what, where he's going and the argument he's laying out with this orange law, but I don't see that as a law the way that I would see like a natural law as a law, because an orange appearing on your doorstep every Wednesday wouldn't really be regular in the same sense that a natural law is, because it's only happening in this one neighborhood. Now, if it was happening in every neighborhood all across the planet, that would be a little different. Another thing is that natural laws are mathematical. These are mathematical relations, usually between different entities or what have you, that are well defined, that we don't have for something like this orange law. It's sort of just like this ad hoc thing that's there. And I get it. It's an example being used to demonstrate a point. But I also think that the disanalogy there, trying to figure out how to put this into words. It sort of demonstrates that we're dealing with something that's not, with the orange example, we're dealing with something that isn't fundamental, that isn't actually really regular, and that is not mathematical. So while I understand the use as an example, when giving an argument, I still think it's disanalogous, and I think that for that reason, it's going to be difficult to lay down the point using that. I would have just used some natural law as an example myself.
So that I can. I think that to get a successful explanation is to be put in a position to understand why or how a phenomenon is happening. There's this link between explanation and understanding. If an explanation is successful, you're in a position to understand the phenomenon. Okay, so if you get a successful explanation, you're in a position to understand why or how the phenomenon is happening. And to understand why or how the phenomenon is happening is to understand a good answer, an acceptable answer to the relevant why or how question. So if someone were to ask you, why is this phenomenon happening? If you really understand the explanation, if it's a good explanation, you'll know a good answer to that question. But in these cases that we're considering where there's this sort of gap or hole in the answer, then part of the answer is like literally unintelligible. It's unable to be understood. It's totally mysterious. So then I don't think you really understand the answer.
Why is the sky blue? Well, the sky is blue as a result of the Rayleigh scattering of electromagnetic radiation from the sun by the gases in our atmosphere, which scatter at a particular frequency. So light at that frequency will get scattered, and light not at that frequency will just pass right through. And the area of the electromagnetic spectrum where this light happens to be scattered is largely in the blue region. And so that Rayleigh scattering of those photons in that area of the spectrum is why the sky is blue, because it's taking those photons and scattering them all across the atmosphere, giving the impression of a blue sky. But why do these photons Rayleigh scatter off of electrons? Let's suppose that there is no even in principle explanation. It's just a thing that photons at this frequency do. That doesn't somehow mean that we failed to explain how the sky or why the sky is blue. I just can't grant that somehow means we actually haven't explained why the sky is blue. We do. We know that it's this Rayleigh scattering that we don't know anything else about. That is the reason why the sky is blue. And that's why I'm pointing out that these are different questions. Why those photons Rayleigh scatter off of electrons, we don't know. There is no we know or we don't know, because there is no explanation for it. That's fine, grant that. But we still know why the sky is blue. We can still use this unexplainable thing to explain other things. I'm just not seeing how you get this sort of like stacking event with lack of an explanation. I don't see how not having any explanation at all, even in principle, for why Rayleigh scattering occurs doesn't mean that it still couldn't be used to explain why the sky is blue. It's not like all of a sudden, nope, that the Rayleigh scattering of photons at a particular frequency across our atmosphere no longer explains why the sky is blue, even though that's why the sky is blue. That just doesn't make sense to me.
The answer to the why is this phenomenon happening? And in that case, you can't really understand why or how the phenomenon is happening. But if that's true, then this isn't really a successful explanation. So again, just think of the neighbors who give you this explanation of the orange. They say, well, it's Wednesday. Okay, we understand that much. At least granting that it's true, wouldn't that explain how this person died, even if, and in this case, there's some mystery regarding Jack the Ripper. We don't know who Jack the Ripper is. We don't know where Jack the Ripper came from. But we know that there's this person committing all these murders. So yeah, I think that's a good case. I would just point out that in order for it to be a counterexample to 2, things would have to be a little weirder than the case that I just described. In the case I just described, like there is some mystery regarding Jack the Ripper. We don't actually know his real name. We don't know where he came from. We don't know why he's doing it. There are all these unknowns with Jack the Ripper. That was kind of what made the case so interesting. But we assume there is an explanation. We just don't know what it is. Surely this person came from somewhere, had parents. Surely this person has some motive. We just don't know what it is. And surely the person has a name. We just don't know what it is. So this would be a case where we're appealing to something in our explanation, Jack the Ripper, and it calls out for explanation. But we assume it doesn't. Jack the Ripper doesn't literally lack an explanation. We just don't know what it is. Right
that's why I was wondering. I was wondering if it's actually a counterexample.
Yeah. So we would need things to be a little weirder. We would need this to be a case where the murderer literally appears from nowhere for no reason, like literally.
Lacks an explanation completely.
Yeah. So then I think things are a little different, because there are examples in the literature from like Robin Collins when he's defending his design argument and he's responding to the who designs the designer objection. He says something like, an explanation can be successful even if we don't have an explanation of the thing that we posit to do the explaining.
Mm-hmm.
He uses an example of like finding a biosphere on Mars or something. Surely we could say, well, I guess extraterrestrial aliens did this, because somebody built this and it wasn't humans. Even if we don't know where the aliens came from and we don't have a further explanation of the aliens. And Alvin Plantinga gives an example like this in his response to Dawkins. I think he talks about just discovering tractors on an alien planet or something and thinking, well, surely aliens built this, even if we don't know much about the aliens or where they came from. So I think that's right, but what we're assuming in those cases is that there would be an explanation of these aliens. And we kind of know how that explanation would go. It would be like an explanation of where humans came from. We've just got these non-human intelligent beings on another planet. But what my premise 2 says is, again, a little bit different. We would need a case where we've got a successful explanation. It appeals to something that calls out for explanation. But this thing that the explanation appeals to literally has no further explanation. So it would be like saying, oh, I found this biosphere on Mars. I guess aliens did it. And then when I ask you, well, where do you suppose these aliens might have come from? I say, no, you misunderstand. The aliens came from nowhere for no reason, and then they just built this biosphere. So there, I think that doesn't really help explain the biosphere. Things just got weirder now. Now we've got a biosphere to explain, and we've got these totally mysterious aliens showing up from nowhere for no reason. So
and that's kind of like the elephant case of the flat Earth.
Yes, yeah. So it's like the elephant case with the flat Earth. You look down under the flat Earth and you see these elephants, and you're tempted to think like, oh, I guess the elephants are holding up the Earth. But then you look a little further and you realize like, oh, there's nothing holding up the elephants. Well, now I don't really understand why the Earth is so stable. I thought I did when I assumed that, there's something holding up the elephants. But when I find out there's literally nothing holding up the elephants, oh, well, I don't really understand why the Earth is so stable now.
So
it's like
would you say that?
But the Earth would still be stable. And it would still be stable because of the elephants.
An explanation can succeed if it doesn't involve something that calls out for an explanation, but that thing does have an explanation, or it can in principle have an explanation?
Yeah, it could feature something that calls out, a successful explanation could feature something that calls out for explanation. It just better have one.
Yeah, okay.
Yeah.
Okay.
Yeah, that's what I think. So
that helps me understand the premise.
Yeah, so I think your example is similar to the kind of counterexamples that have been proposed, though again, we just have to make it a little weirder. So imagine in your case, suppose this really happened. Somebody shows up from nothing for no reason and then just commits a murder, right? Kills somebody else. And now I realize like we're doing the typical philosopher thing where the examples are violent. The examples don't have to be violent. Yeah, we've got a murder happening. You might be tempted to think like, okay, I agree. Person A, the person who showed up mysteriously from nowhere for no reason, that is weird. That is mysterious. But I understand why person B is dead. Person A killed person B.
Exactly. And if that's the reason why person B is dead, then that explains why person B is dead, even though person A came out of nowhere and for no reason.
We don't have to get into the means of how it was done. That would be too violent. But just suppose like you watch it happen. And you're like, okay, I totally understand why person B is dead, even though I don't really understand where person A came from. So examples like that have been proposed. Like, wouldn't it be enough to understand why person B is dead to know that person A killed person B, even if I don't know where person A came from? And in fact, even if there's no answer to the question, where did person A come from? Person A didn't come from anywhere. Okay, another example I've heard is suppose like a pregnant horse shows up ex nihilo for no reason, just manifests, and then gives birth to a colt, and you watch it happen. So this is a nicer, non-violent example. We've got the beauty of even granting that like the origin of the mare is totally mysterious. The origin of the mother horse is totally mysterious. Or here's just a final example. Suppose a meal, some food shows up ex nihilo, totally mysteriously. You don't know where it came from. And in fact, there's nowhere that it did come from. But you're hungry, so you eat it, and now you're not hungry anymore. Can't we explain your satiety, your lack of hunger, by appealing to this meal that you ate, even though the meal, by hypothesis, has no further explanation? Okay, so let me just give a little bit of a response to that, and then I think we'll almost be done. Are we taking Q&A from like an audience or no? What do you think?
Yeah. We have a couple questions that have already come in, so we'll get to questions at the end of the presentation. But I figured that you also wanted to discuss premise 4, right? Isn't that where the slide comes in?
Yeah. Oh, I just wanted to say one final thing about this horse and the meal and your murder case. So I think in each of these cases, there's a part of the proposed explanation that can't be understood. In your case, it was the murderer. We don't understand where that person came from, how that person got here. It's totally mysterious, that person. In the second case, and it has none. In the second case, it's the mare that calls out for explanation that has none. In the third case, it's the meal. But again, what I said earlier was I think that if there's a part of a proposed explanation that can't be understood, then it can't really produce in us an understanding of why or how the phenomenon is happening. But that's a necessary condition for a successful explanation. That
The fact that we cannot explain, there is literally just is no explanation, rather, for where, say, a bowl of cereal came from. Does okay. I just don't see how that means that having eaten the bowl of cereal doesn't explain why my hunger went away, because we know that food takes away hunger. So I guess you could say there's still that regularity that food takes away hunger, and I guess you could say there's still some like initial condition. I eat food, and then I know that okay, so if I eat food and food takes away hunger, then eating the food explains why I'm not hungry anymore, even though there literally exists no explanation for where the food came from. I can't really say it anymore. How is that not still an explanation, a successful one?
it produces in us understanding of the phenomenon. So in none of these cases do we really have a successful explanation. Again, there's a sort of...
And notice how he keeps more asking that as a question. Like, is this really a successful, do we really have a successful explanation? Rather than explaining how we don't have a successful explanation. So, and I just kind of noticed that when he asked that and then realized that's, like, every time he points this out, he seems to sort of ask that as a question rather than defend it as a claim.
Hole or gap in the answer that we're given to how did this person die, or where did this colt come from, or why am I not hungry anymore? We're given an answer, but in each of the cases, part of the answer is mysterious. So there's like a hole or a gap in the answer that we can't understand. And again, if understanding why something's happening or understanding how something's happening requires understanding the answer to that.
But you got to remember, we're granting that there literally exists no explanation for it. Thomas has already excluded things that have in principle explanations. His argument isn't attempting to target those kinds of things. So in the situation when he was discussing the food and the person eating it, it was granted that the food literally just has no explanation. It's not that there is one, but we don't know it. There isn't one at all. Because he's claiming that is what removes its ability to explain, and I'm expressing disagreement with that. You can still explain how somebody's hunger went away from eating the food, even if I grant you your premise that there literally is no explanation for where the food came from at all.
That why question, we can't really understand the answer. So we can't really understand why or how the phenomenon is happening. So let me just say why I think these appear to be counterexamples, why they're kind of attractive. I think it's because although these unexplained, unintelligible parts of the answer create mysterious gaps in the proposed explanation, our minds are sort of disposed to fill in the gaps, so to speak, so that these resemble ordinary cases. Just as our minds fill in like the blind spots created by our optical nerves, we've got these blind spots in our visual fields, but you can't see them because your mind kind of fills them in. I think that something like that is happening in these cases. We're familiar with, cases of violence and murder. We're familiar with cases of birth. We're familiar with eating. And in ordinary cases, if you ask me, are you hungry right now? And I say no, and you say, why not? And I say, because I just, had a little bit of breakfast before this conversation. We're satisfied with that because we assume the explanation will proceed in the ordinary way. We say, yeah, and so on in the ordinary way. Like, you don't have to tell me about your breakfast. I'm just going to assume it's like an ordinary breakfast. So I think we're tempted to do that in the case of the mare. We see the colt come out of the mare, and we're tempted to think like, ah, yes, this is like those other cases of birth that I've seen. Or we eat the mysterious meal and we're not hungry anymore, and we're tempted to think like, ah, yes, this is like the ordinary cases I'm familiar with. But if you stop and think about it, you'll realize this is not like those ordinary cases. And you can bring out the mystery by moving from kind of ordinary cases of murder and birth and eating to the weird cases of like the orange on my doorstep, or something even more alien, like the aliens showing up and building the biosphere from nothing for no reason. Then we better appreciate the mystery, and then I think we're more inclined to realize like, oh, this is not actually a good answer to the question, where did the biosphere come from, or where did this orange come from? Okay, so that's what I say about those counterexamples. I don't think they actually work. So I guess I'll just wrap up and say something about premise 4, and then yeah, that'll finish the argument.
Yeah, so should I put up the slide?
Yeah, let's do that.
Or the premise 4 first. How about we do that?
Yeah, let's do premise 4 first. So premise 4 says, if naturalism is true, then every natural regularity, every law of nature calls out for explanation, but literally lacks one. So there's 2 parts of that premise. I got to say something about why it is that these laws of nature, these natural regularities, call out for explanation, even on naturalism, and why they would lack an explanation on naturalism. Okay, so let me just say briefly, we don't have to get into like different theories about what laws of nature are. I think it's enough to say that like on all the dominant theories about what laws of nature are, they are contingent, and they seem obviously contingent when you think about them. So if you just think about like Newton's universal law of gravitation, that inverse square law, it says if you want to know the force with which 2 bodies will attract each other, what the gravitational force will be between these 2 massive bodies, multiply the masses together, divide by the square of the distance between them, and then multiply that by the gravitational constant. And the gravitational constant looks extremely contingent. I have it here in front of me. It's like 6.67428 times 10 to the minus 11th meters cubed divided by kilograms per second squared, or something like that. Why does it have exactly that value instead of?
Because that's the value ascribed to it by the particular abstracted mathematical system that humans have developed. There isn't like a physically real objective number or value like in reality. There's just a relation. We are the ones that quantify that relation into numbers using math. And in the system, that relation and the rigidity of it is represented by that particular number that we get, and the relations between mass and meters and kilograms and all this other stuff. So when people say, well, why is it specifically this value? Because that's the value when we value-wise, making up words here, but people, I hope, at least can understand what I mean. When we value-wise things, we do that with our mathematical systems. And our mathematical systems are going to, when we value-wise them, have specified numbers and relations. That's all. Now, you might ask, why are these relations this way and why are they this rigid? If there are answers, we don't know yet. There may not be any answers to those questions.
Slightly more.
But if there is, we certainly don't know what they are yet.
Or way less. And then with regard to the form of the law itself, why do I multiply the masses together? Why not add them or subtract them, or multiply them and then raise it to some power or something like that? And why do I divide by the distance of the square between them? Why don't I divide by the cube of the distance between them? It could have been very different, this law of gravitation. It has a particular form, and the gravitational constant has a particular value, and it just seems obvious that these could have been very different. And even for like the most foundational laws of physics, it seems contingent. So it's just sort of a rule that electrons have a -1 charge. Why not slightly more? Why not slightly less? And so on. So all these fundamental parameters of physics and these laws of physics seem like they could have been different. Okay, so they do seem like the sorts of things that call out for explanation.
I don't think that contingency is necessarily something's being contingent is sort of equivalent to it crying out for explanation. That something could have been different than what it is not in and of itself an argument or some sort of necessitating feature for there being an explanation for why it isn't different. Some things might just be the way they are. Now, there could be further explanations for these things. Like I said, if there is, we don't know what they are yet, at least yet. But I also think that it's entirely possible that they could just be this way. I would need to hear a further argument for why something's potential to be different in some way necessitates an explanation for why it isn't. Because just the fact that it could have been different doesn't do that. It just doesn't.
But then the last thing to say is why think that they would lack explanation? So here, it would be great if you could bring up that other picture I sent you. So I hope this isn't overwhelming, but I think these are the possible structures of explanation for natural regularities. Here are all the possibilities. So let's start on the very left. So just pick out like your favorite natural regularity, and we'll just call it R. Maybe it's that universal law of gravitation, or maybe it's some law of thermodynamics, or maybe it's some like law of the special sciences, or a folk scientific law, like it's cold in winter, or when water heats up, it goes up, or something like that. It evaporates and goes up. Whatever the regularity is, just call it R. What we're wondering now is, can we explain that law? Remember, this is like the initial thought. Alan Guth says, I don't know why the laws of nature are the way that they are. And he said, I don't know how to go about answering that question. So we just pointed out that we don't really know why the laws of nature are the way they are. We want an explanation. It seems like they could have been different. So now we're wondering, what can a naturalist say if asked why the laws are the way they are? Can we get a deeper explanation why these laws are the way that they are? So one possibility is no, and that's the far left example, far left column there. And we can just call that simple brute foundationalism. On this option, the regularity that you chose has no deeper explanation. And if so, then I think it's pretty obvious that this regularity is mysterious. And so it's going to violate our second premise if we try.
Out of all of these, I would favor extended brute foundationalism. I mean, once you're at the bottom of reality, there isn't anything more there to account for an explanation of why something is the way that it is. Whys aren't things in the world. They're questions we ask about it. And the natural world isn't obligated to fulfill or answer all of our questions or even have answers for the questions. We ask whys. Whys aren't a feature of the world.
We try to use it to explain any natural phenomenon. So simple brute foundationalism will not help us do science from a naturalistic point of view.
Well, I mean, it could. It could. I don't see why it couldn't.
So what if we tried this instead? Extended brute foundationalism says, well, maybe it's actually true that some natural regularities, especially like in the special sciences, in biology and sociology, psychology, or meteorology, or whatever, they can be explained in terms of more fundamental laws. And then perhaps those more fundamental laws have explanations in terms of even deeper laws. But then eventually we get to the deepest law, the most fundamental law. And then that law, that regularity will be brute. And by brute, I guess I should say, I mean literally has no explanation. So I think this is how naturalists tend to think of the laws. They think that, the laws of biology have explanations in terms of the laws of chemistry.
Hot take, there are no laws of biology. Laws exist in physics and chemistry.
The laws of chemistry have explanations in terms of laws of physics. But then eventually we get to fundamental physics, and that's where things end. In the paper, I have a quote from Sean Carroll who says something very much like that. He says, look, a lot of scientists think that eventually we're going to get like the true theory of everything, and then a little clause that says, and that's just the way it is. That's just the way it is. So if you ask about those most fundamental laws, according to Sean Carroll, the answer seems to be, that's just the way it is. So that's extended.
And that's a perfectly valid answer. Once you've hit the foundation, where else are you going to go for explanations? You're at the foundation. The foundation just is the foundation. There is no explanation for the foundation. And I think that that is a perfectly valid and likely correct answer. And that's because I don't take that there is anything above, beyond, or outside of reality, because those very concepts are incoherent to me. It's like asking what's north of the North Pole.
Extended brute foundationalism. So let me say why I think that that's not going to work. You might see a kind of similarity in that structure and the sort of turtle case. We've got like the flat Earth up at the top. We're wondering what explains the stability of the Earth. We're told, oh, it's on the back of elephants. Oh, what explains the elephants? Oh, they're resting on a turtle, and so on. If this ends eventually, then it's exactly the same sort of structure as extended brute foundationalism. And in the flat Earth case, remember, I tried to convince you that the mystery of that bottom level kind of works its way up and infects the whole structure. Because the bottom level is mysterious, we don't really understand how any of this structure is working. So I think the same thing is going to go here.
Except that we can and do, particularly in physics. I think I gave a couple examples too.
If you just start at that bottom level, we're told, oh, the most fundamental laws of physics are mysterious. They don't have any further explanation. Even though they're contingent and they call out for explanation, the naturalist says there is no further explanation. Well, if that's true, then I think you can't really use that to explain a higher level law. We won't really understand the higher level law because we don't understand the law that's being given to explain it. It's just like the oranges case, it's like the sneeze case, it's like the Earth resting on the back of the turtles case. But if that's true, then we don't understand that, that second level law. It doesn't have an explanation. It's mysterious. And so it can't serve to explain what's above it, and so on. And this goes all the way up to the top. And then the conclusion is, oh, we don't really understand that initial natural regularity. So if this is the way natural regularities are supposed to be explained, they're not going to be explained. Okay, would you mind just bringing up that slide one more time, and I'll wrap this up in the interest of time. I think I'll just leave infinitism and coherentism, and if somebody wants to bring that up in the Q&A, we can talk about it, or if you want to read about it in the paper, you can. I just want to briefly mention why I think theism is better off here. So if you look at that middle column, it's what I call
Prediction time. It's going to be because God. It's better because God. And God explains because he's God.
teleological foundationalism. So that's the view that I myself hold. That's the view that I'm recommending to you, the reader, or the listener. And the way that works is this. You pick a natural regularity. Maybe it's a law or regularity of biology or something. You say, okay, I grant that this could be explained in terms of a more fundamental law, maybe some laws of chemistry. And yeah, that could be explained in terms of the most fundamental laws, the laws of physics. But then on this view, on teleological foundation.
This is actually a really good question, and I'm going to answer with how, like, I almost guarantee you Thomas would answer. Excuse me for a second. And what they're going to say is, because God is a necessarily existent entity, what's going to follow is that God could not have been otherwise. God's existence could not have been otherwise. So it's not contingent. And so number one doesn't cry out for explanation. So we don't really need one. But number two, that since God necessarily exists, that would explain why he exists, because it's necessary. And so God is sort of self-explanatory. So that's how I imagine Thomas, along with many other reasonably well-educated theists, are going to respond to that. That doesn't mean I think that it's good or anything like that, but that's, I almost guarantee you that's the response that Thomas would give.
Foundationalism. That final natural regularity, those truly fundamental laws of nature, they don't have any further scientific explanation, but they do have a further explanation. If you follow Aristotle, these laws will be explained in.
Notice what he just said. Well, they don't. They might have a final scientific explanation, or something like that. But you know, there's one more explanation for them in general. See, everybody grants that there's a ground for explanation. That all of our explanations for everything, regardless of what scale or level, ground out at some scale or at some level, whichever particular term you prefer there. We're all going to agree that there is some place where explanations ground out. It's just that somebody like me, a naturalist, would say, and that's just at the bottom of reality itself, which seems to be, I think at least, a pretty reasonable answer. If, and I want to emphasize that word one more time, if the natural world were all that existed, then it would just follow that explanations ground out at whatever fundamental level of reality there is. Theists just take it one step further, and I'm not saying they're like wrong in doing this or that they oughtn't do this, but they take it one step further and say, well, no, because that's still contingent and still cries out for explanation, re the PSR, which I also reject. So God serves as that explanation, and since God is necessarily existent, that would be the ground of, that's what makes God the ground of explanations. And why they ground out at God is because God is just necessarily existent, and so is self-explanatory. The explanation for why God exists is because his existence is necessary. Necessary things don't cry out for explanations, they're necessary. So, and you can do that. I think that people can do that. I don't see a reason to, when grounding out at whatever fundamental level of the natural world there is, but knock yourself out.
In terms of the final good, that ultimate good at which all things aim, Aristotle's nous, which he sometimes calls God. Everything in the universe is operating as it does on Aristotle's view for love of that prime mover, for love of that nous. Everything on Aristotle's view in the universe is trying to become as much like the prime mover as possible. And so everything's moving to become as good and as perfect as possible.
Stars aren't doing what they do. I'm agentializing, whatever word you want to say, personifying, whatever word it is, something like that. But stars aren't trying to become perfect and good. Good doesn't really, stars do what they do. There's no ought to do with respect to like what just the natural world does. It does those because that's what follows, like Thomas mentioned earlier, from the initial conditions and then all of the various regularities and relations. Reality, I mean, is ought distinction here, clearly. Reality doesn't seek out, it doesn't aim for, it doesn't desire, it doesn't ought or ought not to. Thank you, Brian. Anthropomorphizing. Thank you. It just does. It is that way. And that's that. So when people talk about reality as like trying to or seeking to or any terminology like that, I'm immediately like, what? No, like Hume even talked about this. Reality is. Reality isn't ought. Ought is something that comes from agency, intention, things like that, normativity. And the natural world, save for us, is not normative. So I just, it bothers me when people talk about the world that way.
Possible on Aristotle's view.
And you hear Thomists do it quite a bit, and it's frustrating.
which I think is a really charming view, and I like it a lot. But if you prefer, you could also understand teleological foundationalism in a way that I think is more familiar to a lot of theists these days, in a sort of Platonic tradition. According to Plato, there was this like demiurge, this craftsman, this creator and father of everything that exists. And the view that Plato seems to hold in his dialogues is that if you want to know why the universe is the way that it is, the answer is that this demiurge, this craftsman, which you might call God, wanted everything to be good like him, and so created a universe that would be good.
Created a universe where, for agents like us, which this other agent, this sort of all-powerful agent, this God seems to love and all that stuff, there's a huge variety of natural evils, the 99.999 another like 99 nines of this reality is not suitable for life as we understand it. Some guy decided it would be cool to murder 6 million Jews, like he wanted the world to be good. And then genocides and predation and rape and murder and all of this, it just, what?
Good. And so if you want to know why these fundamental laws of physics are the way that they are, you get the Aristotelian answer in terms of the good at which all things aim, or you get this Platonic answer in terms of the good at which the craftsman or demiurge aims, the good at which God aims. And the reason that I think this option works is ultimately explanations are going to end with something that doesn't call out for further explanation.
I agree that explanations will end, but whether they end at a point where one can't really ask for further explanation, because when I hear that something doesn't call out for explanation, to me that's like would be like something that's either necessary, like what would it mean for it to have an explanation, or something like there really isn't room to ask why or how anymore. And I don't necessarily think that wherever explanations end, that an agent like ourselves with our vast imaginations couldn't still probably ask those why or how questions, and there just not be any at all, any answers or explanations at all, even though we could still ask the questions.
In the examples I was just giving you, we're going to bottom out our explanations with these necessary moral truths.
I think you fucked up when you said necessary moral truths. You should have said necessarily existing agent there, Thomas, but you do you, man.
Know why the laws of nature are the way that they are. On the Platonic view, it's something like, because these are the laws that would allow for sentient life. Why was the demiurge interested in sentient life? Why was God interested in that? Because sentient life is good. And now when you ask, well, why is sentient life good? What's the explanation of that?
Because God said so, huh?
I think we've reached an appropriate stopping point, because we've arrived.
Yeah, I am gonna stop her there. What about an hour and a half? That's not too bad. I thought this would be like 2.5 hours, if I'm being honest. I did skip around a little bit, just because there was, I mean, I don't want to say there was like a lot of repeating, but it was kind of covering similar points and everything. But I don't find this argument convincing against naturalism at all. I don't think that it shows that there's some inconsistency between naturalism as a metaphysical thesis and scientific explanation. And so yeah, while I do think it is an interesting argument, I think this approach as a response to naturalism is certainly an interesting approach to take. But insofar as Thomas' argument is concerned, I don't think that it's a successful argument against naturalism. And so I guess I'll end it there. In a few hours, actually, I'm premiering my first debate that I had at DebateCon, hosted by Modern Day Debate. So if you're interested in that, it's a debate with Wits It Gets It, who I'm sure many of you in the audience will know about. And the topic was atheism versus creationism. I thought it was a really good debate, and I hope to see you guys in the audience later. But for now, I'm going to go ahead and end the stream. You guys take it easy, and I'll see you later.